Hey guys, today we are going to do 2-6 Families of Functions Part 1. You will be able to analyze transformations of functions. So the big idea is that there are sets of functions which are called families in which each function is a transformation of a special function called the parent function. So first, our vocabulary. We have families, which is sets of functions. We have parent function, which is the function with no transformations. Then we have transformations of the parent function. Today we're going to look at a specific transformation, which is called a translation, when we're moving up and down or left and right. We can also call these translation shifts. This is just a look at some of the parent functions we'll be working with this year. You don't have to copy these down. I'm going to give you a copy of this in class. This is our overall equation for transformations of functions. A, B, C, and D are going to transform or change our original function in different ways. Today we're going to focus on C and D. D is a vertical shift and C is a horizontal shift. Here we have a graph of three functions. We have the red, which is our parent function, because there has been no transformation to it, and it is y is equal to x squared. So then we have a parabola. Our vertex of this parabola is at 0, 0. In our blue function, we have this transformation of plus 3 on the outside of our function. And if we find the blue graph, our vertex is now at 0, 3. So what we did was move up 3. Then we have the green function when we're subtracting 2, and the vertex of our green function is 0, negative 2. So this is a vertical shift, and we can move up or down with our vertical shift. So we have we want to know how the function y is equal to x squared and y is equal to x squared minus 2 related. We want to think about how their graphs are related. So since we already know the rules, we don't have to make a table of values, because we just saw when we have x squared minus 2, what happened to our entire graph? It shifted down 2. So the relationship between these two is y is equal to x squared minus 2 is the parent function. Y is equal to x squared, moved down 2 units. And we can see that in our graphs before. If we have the graph y is equal to x squared minus 1 translated up 5 units, we know that originally this function is shifted down 1. So we have a parabola shifted down 1. But we want to move this parabola up 5. So 1, 2, 3, 4, 5. So our new vertex would be here at 0, 4. What we did was add 5 to our parabola. So y is equal to x squared minus 1 plus 5. We can combine like terms here. Y is equal to x squared plus 4. is our new graph. Next we have horizontal shifts. There's a difference between horizontal and vertical because of where we're adding and subtracting. Before we were adding or subtracting on the outside, now we're adding or subtracting on the inside of our function. So once again, we have our parent function, y is equal to x squared in the red, and our vertex is still at 0, 0. But now we have a blue function, which is x plus 3 squared. But if we look at our graph, the blue function has a vertex of -3, 0. So when we were positive, we moved to the left, and when we are negative, -2, we are moving to the right 2 to make our vertex 2, 0. So these are horizontal shifts, and we move left and right. But always remember, horizontal is the opposite of what we would originally think. So if the graph shows the projected altitude f of x of an airplane scheduled to depart an airport at noon, if the plane leaves 2 hours late, what is the function representing this transformation? We're leaving 2 hours late. That means we want to take our original graph and shift it to the right 2. So we have our original function, f of x, but we want to move it to the right 2. Since horizontal translations are on the inside of our function, we have to do f of x. And we either have to add or subtract 2 on the inside of our function. Since we want to go to the right, and we are on the inside with horizontal, we have to think opposite, and instead of positive, we want to have negative. So f of x minus 2 means we're moving to the right 2 units. And just a summary of everything we talked about today. Vertical shifts is when we're moving up and down. If d is positive, we're going to move up that many units. If d is negative, we are going to move down. Then we have horizontal shifts, which is on the inside of our function. We always think the opposite for horizontal. If our c value is positive, we're going to move to the left. And if our c value is negative, we are going to move to the right. When we're working with horizontal, we are going to be working with the x coordinate, and when we are working with vertical, we are going to be working with the y coordinate. That's it.